Build Show Live 2024 conference classes are brought to you by Builders First Source, Huber Engineered Woods, PELLA, and SASHCO. This session is sponsored by POLYGAURD.
Hey everyone, I'm Zach Detmore and I'm here at the first Build Show Live. And none of this would be possible without our amazing sponsors and partners in this event. If you're unable to make it to this one, we are going to have another one next year in Dallas in 2025, so hope to see you there. But I want to take a moment to call out SASHCO. If you're unfamiliar with them, they've been doing this for about 85 years, specifically making super high quality sealants and caulks. The lovely thing about them is they're focused on the end user. They have the customer at top of mind, and that's why I like using their products, because they're easy to work with and they're durable. I'm always concerned about warranties and callbacks, and having a failed sealant is really something that can be expensive because it usually involves repainting or disassembling things, and I don't want that. I'll give you an example to sort of help you understand the difference. So if you think of a fiberglass tub, for example, the fiberglass tub is here, and then you have the tile coming on top of it. And in New Jersey, where I build, for example, if we frame something in the dead of winter, the humidity is very low, so that framing member is sort of compressed as small as it will be. And then come, the middle of July, when it's super humid, it expands, and what happens is the gap between the tub and the tile can open up. And also when you're getting into a tub or you're loading a tub with water, sometimes the fiberglass will come down, maybe you don't have a perfect bed of mortar below your fiberglass tub, and you get movement. The point is, houses move. And if you have a sealant like this, which is sort of probably very commonly used, you'll notice it is stretchy, right? But the thing is, it takes a tremendous amount of force for me to keep this tension. It wants to return back to its previous state. Versus if I use some of the SASHCO products, this is actually very stretchy, much more stretchy, but the cool thing is it sort of relaxes in this stretched state. So it's much more likely that this is going to remain bonded to the tile and to the tub and remain waterproof through sort of the life cycle of the house. And it's very common for me to have to come in and remove poorly installed sealant because of this exact issue. And that's really why I use the SASHCO product line. They have a product line for everything from roofs to windows, and they make a product for each specific application. So if you're unfamiliar with their products, actually click the link in the bio and they'll send you a sampling of any one of their products for you to try out. I highly recommend it. See you at the next Build Show Live.
Well, first I'd like to say welcome. Thanks for coming down to Texas.
Yeah.
For the first time ever, for all y'all to stop working and to come down here, this is fabulous. This is why we're doing it. We get to be in each other's brains. But my name is Mark Wille. Grew up in the building material space in neighborhoods of Chicago, and spent my career working on existing buildings, typically 100-year-old masonry buildings. And then I wanted the easy life, so I built spec homes. And through that whole phase, I did a lot of organization. Yeah, there's a hint, but those buildings we did not blower door test. But we did a lot of weatherization back then and a lot of training for weatherization. And today I'm split between on the road and time in Texas with the family over at Build.
Nice.
Thanks for being here.
Yeah, and I got to thank you, of course, Matt, and the whole crew for inviting me. I'm not part of the Build crew, to be here and be able to speak with all you guys. Appreciate it. Thank you. My name is Randy Williams. I am from a little town in northern Minnesota, about 100 miles south of the Canadian border. Climate zone 7, very cold. I started my career in the mid-90s as an electrician, working for my brother. My brother owns a little interesting company. It's called Williams Septic and Electric. And I'd go to work. I wouldn't know if I was going to drive a dump truck, if I was going to be running a shovel, or if I was going to be wiring a house. So we learned quite a bit. That's where I learned a lot of what I know about building from him. Eventually, I moved into general contracting. I became a general contractor. 2005 to 2015, I worked building new homes. I've got 20-some new homes on the market, a few light commercial structures. We tend to do everything except for the trades, the mechanical, electrical, plumbing trades. When we were building, we were the framers. A lot of times we were the concrete people. We were the roofers. We put the windows in, put siding in, put cabinets in. We did everything. So you learn a lot about the process. 2009, of course, we know what happened. 2008, 2009, we had a little downturn in the economy. I decided I wanted to expand my business just in case. I took some energy auditing training, learned a little bit about building science, latched on to Building Science Corporation, and of course Matt and this whole building science community, and kind of grew from there. Started writing a blog. 2018, I started writing a blog. 2020, 2021, I had my first article published in Fine Home Building.
Okay.
Strangely enough, they put me on the cover, which I have no idea why they did that, but I appreciate that.
Handsome looks.
And I write for both trade publications plus GLC.
Yep.
So I'm around a little bit.
The first time I met Randy, and by the way, how he introduced himself is how I think we should all get accustomed to introducing himself. He said climate zone 7. So if you're ever bidding against another contractor and you told that client that your climate zone, this and that, the other guy's not going to be able to answer that. So it's a nice conversation starter, but we met while he was presenting with Peter Yost. And so a lot of us, we really love Peter Yost. He's also here this weekend, and that was the first time we actually met.
Yeah, yep. They're our sponsors. We appreciate them. And of course, Matt. Okay, this leads to a question. Are we building too tight? And we'll get to the answer at the end. We're not going to let you get out of here half hour, and you got to wait. So, tight. What's tight? This balloon. We're not leaking any air, right? Where will this work? Could we build a structure like this in our communities? Yeah, we could. It'd probably be really expensive, but we could. But it would work on the moon. We could, if we could build this tight enough, we could work on the moon. We could put it in the ocean, stuff like that. It would work. Houses that we build, they leak just a little bit, right? Just a little bit. At least the ones that Jake builds. They leak just a little bit. Jake Bruton. And hopefully a lot of us are building that way now. I live in a house that was built in 1952. It leaks like that. You know, I did a blower door test before I actually bought it. It was at 12 ACH 50, and we're going to go over some of these metrics so you know what they mean. But that's a pretty leaky, especially in northern Minnesota, very cold climate. That's not good. So
this is a question all the time, right? And it's so true. And we always say, how do we determine that? Like, how do we know? And the answer is always the same. Either you do it or you call someone and you
test. You've got to test. There are areas in the country that I've heard about that they get by with a visual air tightness test. They walk and wander around and just look to see if the big points are hit. You don't know. You don't know how you did. You don't know. There could be a big bypass in there someplace that's leaking like crazy. So you got to test. That's the only way you know.
Has anyone here come from weatherization?
Yeah.
We got a weatherization. What year?
Oh, no, I guess I lied.
Okay.
I'm doing weatherization.
Got it. So it's exactly right, though. In the beginning, we'd walk the buildings, and we'd determine, should we test them? Mm-hmm. We did that with our eyes. And I have a feeling there's a lot of buildings I screwed up on by using my eyes.
Yeah, yep. And we're going to get more into what can happen, of course, if we go the other way and do make them really tight. That's the whole reason we're here, right? So, how many of you seen how a blower? Have anybody in here run a blower door? Let's start with that. Okay, so we got a few.
That's a pretty high percentage.
Yeah, that's good.
That's about 8%.
How many of you own your own blower door? Good, good. So you guys know how a blower door runs. This is a quick video. This is a unique instance. So we're under negative pressure. We shut the blower door off. You see that? That's an inrush of air back into through the fan. That is not common. That does not normally happen.
Actually, Red, I want to ask, has anyone that's run the blower door, have you seen that happen after you shut it off, you still get the flow?
That's typical.
Maybe?
Whoops. Usually it's the air just drops. You've got enough leakage in the house where the pressure just returns to normal real quickly. That structure, that's actually a barndominium that we were involved with 3 years ago.
So what was the square footage on that?
10,000 square feet.
Okay, if it's 10,000 square feet, you could all associate that, that's being roughly 5 times a normal house.
Correct.
And then the cubic footage?
160,000 cubic feet. So the typical house I test is in the teens, to 15,000, maybe 20,000 on a bigger one. This is 160,000 cubic feet. That structure tested at 0.38 ACH 50. That's with 3 huge garage doors. That's the whole structure. We were testing the entire structure at one time. The air leakage rate was 1,000 CFM, which seems, when we're going to get into the CFM, that's, this is a little bit smaller, but roughly a CFM, right? That's why I have these there. If you think one of these, that structure was leaking 1,000 of these per minute through the, and that's tight. That's really a tight structure.
Yeah, that's pretty much exactly cubic foot.
Yeah.
Exact, in fact.
So having that airflow back in, it's compressibility of air. The structure was so big and it was tight enough that as the blower was running, it took forever to get to a steady state of 50 pascals. It was compressing the air. And then when we shut the fan off, of course, that air, it couldn't get in quick enough, so it came in through the fan. A unique situation, like I said.
Does anyone know what it is, right? What is a Pascal, right? What is 50 pascals? Why do we even choose it? What is it equal to?
Yeah.
We had to come up with something.
Somebody did. We're just using it.
Lucky to have it.
Those first few, I actually got that from Peter Yost.
Yep.
It was part of Peter Yost's, one of his presentations. A Pascal is equal to 1 Newton per meter squared. Who knows what that is. We get that down to this third one. A Pascal is equal to 0.004 inches of water column. That's not much. That's a really, really small pressure. 50 pascals is equal to 0.2 inches of water column. So when we're testing, if you put a straw in a cup and you suck up on that, you're sucking up 3/16 of an inch.
That's it.
That's the amount of pressure that we're testing a house at. Now you take let's take a 6-inch sewer pipe and throw it in Lake Travis out here, and let's see you suck 3/16 of an inch out of that. You're not going to happen. It's not going to work. When you get into the house, of course, you get a lot of volume. So it seems like but it's a very small amount of pressure that we're testing. It's roughly a 20-mile-an-hour wind blowing on all sides at the house at the same time.
That's the important part. It's the complete engulfing the house.
Yes. So residential, 50 pascals. Commercial, we're typically at that 75 pascals, excuse me. 25 pascals is a duct tightness testing. Hurricane force, a force on a house. You're in that 80 to 110, even way over that it can be. You're 1,500 pascals at 110 miles per hour. Does those forces happen on a house? Yeah, obviously, yeah. Hopefully only once in a while, hopefully, but.
In typical, you're not going to see the 20 happening on all sides of the house.
No, this is an artificial pressure.
Which is why it's a nice number, because it's going to be worse than most cases that house is going against. If we're trying to do our worst case, then let's go against our best.
So what is tight? We got to answer that question before we can figure out if we're building too tight, right? What is tight? This is a multi-point test. For those of you that don't do blower door tests, we can use a computer to control the testings, right? Multi-point test starts sampling pressures at this particular one at 60 pascals. It does 100 samples at 60 pascals in my software. And then it drops down to 54 pascals, and it does another 100 samples, and it continues until it gets to, I think it's 16 pascals. And then I can draw a line. The software will draw a line on the program. With this information, I can figure out what the leakage rate is for a bath fan. How many pascals the house goes negative or positive, if it would be negative if a bath fan or some other exhausting fan is operating. But let's say we had a 100 CFM exhausting fan, we knew we'd be, you know, roughly 4 pascals, something like that. Is that a problem? If the house goes 4 negative pascals, is that a problem? We're going to get to that in a little bit. So what do we use for metrics for airtightness?
Are you familiar with the CFM or the ACH? Okay, that's 2 people. Is everyone else familiar with CFM and ACH? Terrific. So we're using that cubic feet, right? So today, though, we're branching forward.
Yeah. So when we're running a blower door test, the test is actually measuring cubic feet per minute going through the house. These other metrics are mathematical equations based on that number. That CFM number is the most important. You know, a project I have going right now, we'll talk a little bit about this again later. I have got a CFM rate of 60. That's very, very low. But you got to take that in context. That other house that I was talking about, that barnuminium project, that had a CFM of 1,000. Is that tight? Well, it was in that case, but you stick that under a normal house, that's not, it may not even be a passing blower door test under a normal sized house. So most of the numbers that we're manipulating are going to be, I mean, we need the CFM to start with, but then the rest of it's going to be dependent on the other metrics of the house, whether it be the surface area, which is something that we're starting to move towards. Passive house has
All the time.
moved to that now. If the 2021 energy code will allow you, if you have a very small house, to use that metric, less than 1,500 square feet.
That's it.
So it helps with the smaller structures. I guess it equals the playing field. Because if you have a big house and you have at that ACH 50 number, and that's the only metric you're looking at, the big houses have an advantage. The smaller houses are at a disadvantage.
We get to play with the surface area rather than the volume.
Yes, and where do leaks happen? Not in volume, right? They happen on surfaces. So it makes more sense for the lower number, but not everybody understands that yet. That's going to be a process a few years before we start seeing that become more common in codes.
Totally.
We've already covered it. Yeah, it induces an artificial pressure. And we can estimate the leakage rate. You know, we're testing, like we mentioned earlier, houses at an artificial pressure. This up there, this is actually that picture.
Has
Anybody
anyone seen this?
seen one of those gauges? Yeah, that's how we used to control blower doors. I just brought it with, that'd be cool.
Do some close-ups here. It's something.
You can pass it around if you want. So that's how we used to run our blower door testing. That's from 1990. I wasn't blower. Yeah. Actually, if you go to the Energy Conservatory, Minneapolis blower door, if you go through their factory, they use those gauges to calibrate their equipment. They're still using that equipment.
And you got to do a little more thinking with those too, right?
Yeah.
Thankfully, the devices do it on the back end.
Yeah.
So, Randy, this is something that I haven't come across, right? This is a different tier. So.
Yeah, we're getting into the weeds.
When I see it, I'm like, I don't even know what you're up to here.
Yeah, yeah. So when we're figuring out the leakage rate of a house, of course, we're at a given rate at a given size, right? ACH 50, whatever that number is. So let's say you have a score. Let's say you pass a score, a blower door test, a code-compliant blower door test, and you hit the 3 or 5 ACH 50. That's at that artificial pressure, right? How can we figure out what the house will, or at least estimate what the house's leakage rate is naturally? Yeah, we can. There's a formula for that. This is the Lawrence Berkeley National Laboratory, I think, came up with this estimate. It's rough because leakage happens on surfaces, like I mentioned earlier. It's very dependent on where the hole is, the shape of the hole, of course, the size of the hole, and then the driving pressure, you know, how big of a pressure. That all changes how a house will leak. But this will give us an estimate to figure out what, if we're at 3/8. Well, let's use this one as an example. A home located in zone 1. This is not a climate zone. This is a different zone. Located in zone 1. So if we picked northern Minnesota, the western part of northern Minnesota, that's about where I live. Zone 1. It has a normal exposure, so we have a different exposure rates that we have to look at. Well shielded, normal, and exposed. Exposed, of course, is kind of in the middle of nowhere. You have no tree or very few trees. The normal would be a normal residential neighborhood. A well shielded would be lots of trees and tightly closed houses. You know, that's kind of how would you use that. Based on the site, and then you go across, you have a number of stories. So my house, let's say it's a 2-story house, climate zone, or that zone 1, not climate zone, but zone 1. I had a blower door test of 5. We use a mathematical factor, and over in the lower corner there, that's the natural air leakage rate, 0.4 ACH 50. So every hour, 2.5 hours, you're leaking the entire volume of air in your house with outside air. That's, you know, he had a blower door test of 5 for this particular structure in that location. That's what you would expect. Again, it's an estimate. It's probably way over that in the wintertime. It's probably less than that in the summertime. But on average, you're in that neighborhood. So let's look at a really tight house. Passive house level of air tightness. If we go over to the same identical house with passive house, 0.05 ACH, right? Once every 20 hours now we're leaking. Instead of every 2.5 hours, it's every 20 hours we're leaking all the interior air with outside air. That's tight. That's tight. What effects can that have?
It could be problematic.
So what is tight? Code built house, depending on where you're at and these are codes. It started in 2012. Your codes may be a little bit different. Minnesota started their requirements for blower door testing in 2015. We're required at 3. If you live down here, it might be 5 ACH 50, air changes per hour, 50 pascals. My goal for new construction is 1. Any project that I'm involved with, that's where I want to be for air tightness. Passive house.
They're doing the ACH at 6, right?
But they've gone to a little bit different metric now too. Yep, the 0.06 per square foot of surface area. Yep. Tightest house. This is I wrote this or designed this the presentation 2 months ago. Mm-hmm. At the time, that was my tightest house that I'd ever tested.
Well, of course, they also have 2 windows and 1 door.
Well, this is the world record. Yes. But the tightest house that I personally tested was at 0.3. That's no longer right. It's now 0.3. That house that was leaking 60 CFM was 0.3 ACH 50. The world record 2012 0.05. And we don't know. I tried to figure out if there's anything more to date. But like you said, it's 3 windows, 2 door or 1 door in Alaska. Oh.
It's a nice goal, but that's not the That's not the point at all.
Okay, now we're starting to move into why you're here. Are we building too tight? What can happen when we build a very tight house?
I get scared. I've always gotten scared because it's only part of the conversation, right? And when we're trapping all that in, what are we doing to control it?
Yeah.
Are we thinking about our dehumidification?
If you're building tight, you better be. You better be thinking about that. You better be thinking about fresh air for the people that are living in the house. You better be looking at the equipment that you're using in the house. You know, are you using an atmospherically vented some kind of appliance?
Because they're still the majority.
You know, there's things that we need to think about. Planning is key. You've got to plan. If you're that structure that I have that's leaking 60 CFM. Anybody know what a dryer exhausts? Roughly? Yeah, 130, 150, maybe 200 if the ductwork's perfect and it's a good fan on there. Every time that dryer's on, I'm doing more than a blower door test on that house that's leaking 60 CFM. Is it going to reach 100 pascals when the dryer's on? Probably not. But it's going to take forever for the clothes to dry. You're not getting enough air through there. It's just, it's starving for air. There's other pieces of equipment that are even worse than that. So that's a dryer, you know, that, like you said, 130, 200, maybe up to 200. Bath fan. If it's ducted right, not like that one, where there's a circle like that. But a good ducted bath fan might be 50 to 100 and some CFM on a high setting. There's a bigger one. What ranges? Get the range hoods. Those are scary. Those are, you're at 1200, you're doing, yeah, somebody talked you into something you shouldn't be doing. 400 CFM on the high end. At 400 CFM, you're actually required to make up air systems.
But that's based on code.
That's based on code.
And if you're tighter than code,
You might want to be thinking about something else. Yeah,
It'll help you
exactly.
open your door.
Or close it, yes. Yeah. So some of the considerations we need to think as we're starting to get into these tighter structures. So this was my house. Even though it's very leaky, I've now got it down to 9 ACH 50. So from 12 to 9, I'm still not done. I got a long ways to go. My goal is 3. But at 9 ACH 50, I turned my dryer on, I turned my kitchen range hood on, I turned my bath fan on, and I went in the basement by the dryer, and that's where my house was, -5 pascals, in a house that's leaking 1,000 CFM. So you're still, you have the possibility of.
It's pretty remarkable, actually.
Yeah, yeah. Is that a problem? Is -5 pascals a problem? It depends. Unfortunately, that's an answer that I'm going to say a lot, but it just depends. Okay, so we talked about that. We showed this graph a little bit. Let's talk about that 400 CFM exhaust fan with this house that had this leakage rate. If you follow that number over and down, we're roughly 20 pascals negative with this particular house with a 400 CFM bath fan running. Is that problematic? And it depends again. It depends. You know, what's in the house that can be affected? Things that things we have to be thinking about as we move along the process of designing these houses.
This is my whole career. This is all we did.
Yeah.
And it was never actually this neat. So that's what scares me when these buildings are tightened up, that this is going on.
Mm-hmm, mm-hmm.
And also when you go to testing, it's a whole different thing.
Yeah. Yeah. So all these pictures are pictures that I took on jobs. Jobs I wasn't involved with the building, I was there for testing. With the exception of the far right one. I was actually involved with that one. Water heater, this was in a 2021 build.
Sure.
Somebody put that in a brand new structure, 2021. That was the combustion air for that water heater. That's a fresh air. It's just a passive, so as the building were to go negative, hopefully, and supplying enough air inside this room for that.
what's the duct size?
That's I think that was a 6-inch. Yeah, so it was a wide open duct right to the outside. You suppose that affects the blower door score? I can't seal that. That's an open, when I do a blower door test, that's got to stay open. It moves a lot of air through it. When you start getting into tight structures, so this one, that's a makeup air system. That's actually a heated makeup air system. Why did we decide to put that one in? Because we got a tight house. It was 140, that particular house was 140 CFM air leakage rate. So at 50 pascals, we had 140 balloons moving through that fan per minute. That's very tight. That particular house had a 250 CFM exhaust fan and a wood-burning fireplace.
Oh.
So I was a little nervous about that. Well, and the dryer too. The dryer was exhausting. So somebody had the dryer and that big kitchen range hood on. What happens if they have a burning fire going? You open the doors up and you got logs flying at you. I mean, there's stuff coming out of that thing that are not good. So we talked to home, and I said, the only way I'm gonna let you put this fireplace in this house is if we do a makeup air system, or, you know, to make sure that we're staying really close to zero when your exhaust fans are on and you've got a wood burning. That was a plan. That was a conscious plan that we put together. Now, of course, people living in Minnesota, that I think was capable of 500 CFM was the intake. That's a lot of cold air that has potential for being drug into a house.
Did you have some sort of door on the fireplace with a switch for the makeup air kit?
Nope, there's actually CT current transformers that are around the range hood and the dryer, so that when either one of those on, and it recognizes which one's on, it adjusts its speed so that we're not going positive in-house.
What if you're having a wood burning fire?
As long as those appliances are on, it takes outside air. The actual firebox takes outside air for combustion, so it's not using interior air for that.
We're not required to put a door on it with a switch for the makeup air kit.
Okay, so if the door is open, the makeup air has to come on? That's crazy. I mean, okay.
I'd love a photograph of that.
Yeah, I would too.
I haven't had to do it yet.
Okay,
Yet,
yeah,
but I get why they ask for that, yeah.
yeah. So we want to keep, and like I was saying, Minnesota, it's 20 below out, and they decided to turn these two appliances on. Last thing you want to have is 20 below air dumping on somebody in the house, right? So we have a makeup air, I mean, the heated makeup air. There's an electric plenum heater in there that. How much does it what?
Actually bring that negative
It depends on the outside temperature but even if we got it up to 50 degrees, that's way better than negative 20. So, yeah.
As it know, like, if you're shooting 400 CFM through there, how quick is that?
It could be bigger, but that's a 5 kW heater. You know, so that you're what, 15,000 BTUs or something like that. Yeah. So again, we're thinking about what we can do and what we shouldn't be doing in these houses that are tight. Again, combustion air or makeup air systems. Anybody putting those things in the middle photo? Anybody putting those in anybody's houses? Good, don't. That's a ventless heater. So you turn it on and it's just putting moisture in your house. It's if it's not running right, it could be CO that's coming in the house. Yeah.
And they're usually placed in the wrong spot,
Yeah.
or problematic zone, I would say.
Last one, that equipment is very reliable. It lasts forever, but it's not. You don't use that in a tight house. Sealed combustion's fine. Atmospherically vented, where it uses interior air and it's got a space between the exhaust and the appliance. That is scary. It doesn't have to go. It only has to go 3 pascals negative in a structure like that in that room to backdraft those exhausts.
And it'll keep doing that.
Yeah. And if the appliance is working correctly, the worst thing you get is water vapor. If it's not burning correctly, you got CO. And it may be a low-level CO where people don't really realize they just don't feel good in their house. They're flu-like symptoms, headaches. Worst case scenario, you're killing occupants.
Sleeping a little longer.
Yeah, or not waking up. That's, yeah. To the left, that's a boiler. So that's a atmospherically vented boiler. Yeah. Yeah, if you're a mechanical contractor, hopefully you're sizing, you've got to have so much cubic feet of air inside of a specific space for appliances like that to run. It's, I think, 50 cubic feet per 1,000 BTUs of heat. So, you got to plan for the space. That one does have fresh air. You can see that little silver between the two. Yeah, it's pulling a little bit of combustion air through that. But not the systems that you want to be putting in an extremely tight house.
Makeup air products for residences? Because I'm here in Austin, it's kind of a problem.
I would imagine somebody would be, although you gotta slow the rates down on those quite a bit. You can't have that high CFM coming through to cool and dehumidify. I know there's some ERV, HRVs that have them built in, but they slow the rates down, and that's not for makeup, that's balanced ventilation. That's not a makeup air system. Good.
Like every house we do has a 1200 CFM that way.
Yeah, and it's just a wide open.
Makeup air with the
Yeah.
But I don't want to bring in
Yep. So the expo floor, start chatting with those guys. I don't know the answer. That's a good point, though.
You can crank the CFMs up on
You can try. That's the manufacturers usually don't like to see you do that.
Yeah.
They want to maintain balance with those systems. I know we were trying to for a long time. I wanted to use an ERV or an HRV to balance the pressures in the house. That was my vision, is to have some way to monitor pressures inside and use that appliance to. For whatever reason, the HRV and ERV manufacturers saying no, you can't do that. And as a matter of fact, the new equipment it comes so that it balances itself.
Self-balance.
Yeah, it really, but again, talk to manufacturers and see if because this equipment is changing so quickly. These are problems, of course. We already talked a little bit about those. These are all homes that I've been in. You run into the 1970s center picture. That's an open hearth type fixture. You know,
There's primary problems and secondary problems. Stacking the cords of wood that you often find is another driver.
like
Oh,
that?
Here we go.
Like that? Yeah. Yeah, what's that doing? You bring all that in your house, you know? And I said, that's actually a picture I took. Yeah, that happens. A little bit of moisture load. It's okay. Minnesota, we get down to 20% RH in the middle of winter. That's okay. Yeah, that's problematic. And again, another picture I took, I was doing some insurance inspections for a couple of local insurance companies, and I came around the back side of the house and I saw that, and they didn't have insurance for very long. It scared the company. Maintenance on the equipment. How many are you installing ERVs or HRVs in houses that you're good? I like to see that.
That's 40%.
Yeah, nice. Minnesota has been requiring us to install that equipment since 2004. We are very well versed on primarily HRVs, but with the new ERV systems out now, we can use both.
Yeah, just for our knowledge, the folks that are doing ERVs, could you just give your climate zone or city? Just go from this row back.
2A, 4C, 2A.
4, 3, okay, that's good. And you guys are getting obviously your houses are becoming very tight, I'm assuming. You're 0.45, good. Anybody else? No? 1? So, and that's perfect, that's a great score.
Is there any kickback on the additional appliance?
You can do the 45L credits, but it doesn't give you enough to offset the cost of the additional.
Yeah, they're not the cheapest. When you get into the high end, the Zenders, you're in a. Okay.
But it's part of the business model. Regardless of the client, the ERV is
It's
part of it.
required in our houses because anything we build is going to be 1 ACH 50 or less.
Mm-hmm.
So it's a requirement. For
Good.
us And a deacon.
I encourage folks to put it in the contract and make someone take it out.
Yeah.
Biggest thing with these that I find is maintenance. I was at one a week and a half ago. They actually had a bee's nest with all the debris right at their intake. That one was not, and I asked the homeowner, the unit had been operating for the past 7 years. She didn't know she had to clean it. She had no idea, you know? So it hadn't been maintained in 7 years that she owned the equipment. They're very clever in how they work. It's just basically exchanging temperature out of the airstreams. The airstreams don't touch, but the temperature, the differential. So if you're cooling or heating, you're moving some of that temperature out to, not in my climate, not be bringing in the 20 below air.
Small mitigation.
Yeah. Yep. Anybody testing indoor air quality? Radon with tight houses can be problematic. You know, at my house, as a matter of fact, that graph on the right, that's my house. That red line on top is 4 picocuries per liter. That's the part where we start to get worried. The lower part, I think, is 2 picocuries per liter. So that's maybe a month worth of data. That's how much a radon will change inside a house. And my house is leaky. I'm worried that once I get my house tightened up, I'm probably going to see an increase in my radon in my basement. That's problematic for me.
What kind of foundation?
That's block. 1952. It's block and a really poor concrete floor. I mean, it's there, I guess, but yeah.
More typical than we know.
Yeah. Back to the monitoring, though. Those are all systems that I have. I play around with this equipment quite a bit.
What's your favorite one?
I like the air things, the second one. That one actually does radon. I do have the radon eye also. They don't exactly match. You look at them and they're not the same all the time, but they're close. The third one, CPS, that's actually the model I take when I'm doing investigations. So I'm on an energy audit or a building investigation, I'm using that one. I'll run it for an hour. It's not great for just 1 hour of data. You really need...
Small base.
Yeah, and radon's even worse. You should have at least 90 days. That 4, 5, 6 day test isn't enough. You need 90 days. As you can see, I mean, on my next slide, that's how much it varies. You don't have a good reference at 4 or 5 days. It's 90 days minimum. Humidity, controlling humidity is key in these structures. I see that the first picture with the frozen stuff coming out the soffit vents. I see that quite a bit in my climate. Not what you want to see. That's a moisture issue and it's an air leak issue going into the attic space.
Major leakage.
Yeah. Second picture was my brother sent me that picture. I happened to be at IBS and he sent me that one. He says, is that a problem? The brand new house, under construction. It was insulated, and the contractors, I don't know if they didn't get paid or what, but they kind of left the job. And it was hot, or it was humid in there, but it was cold outside, and they ended up with this nice little, I can't remember what they call that, the face things, whatever that is.
I was going to ask, how soon after construction was that investigated?
Well, my brother was there, that was within probably 2 months of the time that they started to where they got to that point. Yeah. Monitoring humidity levels inside houses, that's something that I recommend anyways, but if you're building tight, you want to make sure you know where those are maintained. And whatever climate you're in, my climate, depending on the house, 30% is where I like to see them in the wintertime. Your climate, if you're in a more warm climate, you may not be able to get it to 30% without dehumidification.
And if you have a heat pump water heater, maybe you're enjoying that dehumidification.
Yeah. Anybody know where the point, the humidity where too high is too much? You know what that relative RH? 60%? Yep. 60 is about the highest that we want to see a house. 70% is where we start growing biologicals. So you want to have that little bit of a fluff in there at some point, so you're not that close. And how do we dehumidify? You guys know, southern climates know the dehumidification way better than I do. We see the room units in our basements. In northern climate, they run in the summertime just to kind of maintain the basement so they don't stink.
2 months.
For 2 months, yep. Down here, of course, that's way more common. We, in a northern climate zone 7, every new house gets an air conditioner or heat pump. We can't handle heat anymore, apparently, up there. We whine when it's 80. At least I do. I don't know about everybody else, but I do. And then air exchangers. In my climate, an HRV will control humidity in the wintertime. I can get a house, if I want to run one of those wide open, I could get the house down to single digits if I wanted for relative humidity. You got to play with them to get them set right for the specific house. But so how tight is too tight? Now we got to answer the question.
You have a number?
It depends, right? It depends, unfortunately. So thinking about what you're doing, controlling humidity, making sure the occupants have good fresh air. Don't use atmospherically exhausting combustion appliances. If combustion air appliances are used, which is fine, they have to be sealed combustion. Better if you can eliminate those and move to the heat, especially the heat pump technologies and all those are great. Monitoring, as a builder, it's hard for us to monitor the homes. A lot of the equipment, it's a little bit tougher for us to gain access to it. At least get the homeowner, try to educate them, making sure that they're monitoring. If there's a problem in the home, you want to find out about that pretty quickly. You don't want to be waiting till the last, till they got a problem with their health or a problem with the home to find out that there's an issue with the.
For the folks that were listening at the early part before the presentation, that's why we brought up the joy of the sensors, because it gives us the heads up before the problem happens to the client, which is a mutual responsibility.
I have a desire to monitor our houses for years after we built them. Do you have any recommendations on any sort of remote monitoring equipment that we can tap into without the homeowners can't see it?
Yeah.
For transparency, I wouldn't do it. I would keep it, because let's face it, they don't know what a furnace filter change is in most cases. So if they're learned and you happen to be away on vacation, then at least you get the call from them first. So I would give it a dual access, but I could send you links. And I would encourage it because I'm not seeing anyone in this market using it at all. So you get a way of kind of tapping into what needs to be done in your area, so you lead the charge that way.
Zender, from what I understand, is coming out with a suite of monitors for their equipment. Not that you're using Zender equipment, but usually if one manufacturer's got them, usually the rest follow suit pretty quickly. Eventually, hopefully, what we're going to start seeing are wall, just like the thermostat, some kind of a wall control unit or something that's tied to the ERV, HRV, and is getting us the right air quality that we want inside the house.
Finding it more in residential, right? We're just before the wave.
Yeah, I think we're close. I think we're very close. All right, questions? Anybody? So what is too tight? Everybody knows what too tight is now? The goal should be 1. The goal should always be 1, and then get rid of the nasty stuff that might bad things to the occupants or to the house.
And that's that careful equation. If you're chasing that lower number, before you're chasing that lower number below 1,
make a plan.
Bring in that air.
Yep.
Sorry, you guys might have touched on this. What are your thoughts on using ERVs to maintain a slightly positive pressure in-house to help combat some of the downsides of running exhaust fans and stuff that are going to take a house negative? I mean, are there any downsides to keeping a slightly positive pressurized envelope?
Depends on your climate. So if you're in a climate like I am, climate zone 7, if you go positive, you're pushing potentially warm, humid air into wall cavities where, depending on the assembly, you could end up with some moisture, some frost. I've got all kinds of pictures that I've taken over the years of attics and walls full of frost. I've had times where I couldn't pull the insulation out of the wall. Half of it stays because it's so wet behind there. That's the issue with positive pressure in my climate. Now, if you're in a dry climate, it's more temperate. It probably isn't Southern California. There you go. Yeah, probably fine. Yeah.
That's the commissioning part, but your head's in the right spot. I
Yeah.
totally agree with that.
Yeah. Think about it. Think about where you're at, what you're doing, what could happen. Yeah.
Thank you. So when you test and your ACH is 1.5 above what you want to achieve, how do you know where to seal properly?
Where to seal?
Yeah.
If you're shooting for a goal and where do you want an air seal to make sure you're hitting that goal?
Where is leaking? How do you know where is
leaking?
leaking?
So can we back up? Are we talking for new construction?
Yes.
Okay. So my first step would be the timing of that test. So in most cases, I would encourage you at the time when your sheathing and your windows are completed and perceived to be sealed, try to do the test at that stage. Don't wait down the road until after the insulation and drywall is up. because the remedy gets harder.
Yeah, depending on where your air barrier is, definitely.
With the siding as well. If your air barrier is your
If you're, yes, if the sheathing is your air barrier, do it perfect. If the sheathing is your air barrier, do it before the cladding as well. And then you could go ahead and roll that back if you really want to test what the cladding's doing to that air barrier. But I would always try and do it before you insulate. Now, you might be using close-out spray foam as that air barrier, in which case immediately test after that's done. But do it at that stage. And then there's standard points. You have the long linear fashion of your rim and of your base plate. That is a culprit. And then typically where the union is of an opening. And so a rough opening is usually a call for the window, but on that same schedule is your electrical penetration, mechanical penetration, and a minor plumbing penetration. So those are your culprit areas. If it's not those areas, I would tell all of us who that contractor is so we could have lunch. Because those should be areas, right?
Yeah, the lid would be the only other one that you would,
Yeah, but you would usually know it's wet before you know there's air, unless it's not a rating season.
yeah.
Yeah, the lid.
Found by sealing base plate, like, pay more attention to the bottom plate, that we got better.
Yep. Yep, bottom plate, and my biggest one is the wall to roof connection, and then the foundation to wall connection. If you got those, and windows, of course, doors.
What was the simple step you used for the wall, for the
So we
bit,
started
for the
with
plate?
like a zip liquid flash.
Mhm.
We found the time that it took to do that.
You did the flash from the,
We did like edge of the sheeting, bottom of the sheeting, base plate, edge concrete.
Good.
instead of that base plate. But we've since gone to like the seated ventral tape.
Mhm.
Just the speed of that
Mhm.
it's amazing.
Yeah,
and it was $200 in material and 5 hours of labor.
yeah, yeah, and I use the same detail. That's it.
That's the weak spot
are
in
you-
a lot of cases, to your point.
Crawl space basements or slab? But you're insulated interior in the slab, or, yeah, we're insulated exterior in the slab. So that, you can't insulate, you can't put the tape to the insulation, especially rock wool, that doesn't work very well. And so I have to leave that insulation off until we have that detail done, and then we come back in and put the,
Added.
yep, yep, yep.
protect that detail with a piece of flashing.
Yeah, it needs to be protected, yep,
Weed eaters will destroy that,
yeah,
first 6 months they live there.
yeah.
Yeah, you're anticipating problems.
Unless you're high enough off the ground, then you're safe, but yeah.
Even if you're 12 inches up,
You-
that weed eater's gonna come.
Yeah.
Under what circumstances would you recommend a HRV over a ERV?
Actually, we're seeing more and more ERVs just become the norm. HRV, if you've got a swimming pool in your house,
Yep.
I would think about putting an HRV in. If you have single pane windows and you're in climate zone 7, and you need to keep that humidity, because those windows will become dehumidifiers if you do not keep your
That's only
humidity
gonna
low.
help it. It's not gonna alleviate the problem.
Right, right. But even in my climate, we're seeing the shift to an ERV. They're built better today. The membrane that they're using for that heat transfer is no longer sensitive to moisture, whereas in the past it was, and it would fall apart. That's why,
The sales volume of the HRVs has gone so down, and it's not just what the contractors are calling for, the manufacturers like, yeah, based on how we're building, yeah, okay.
yeah.
So if you guys were putting a wood-burning fireplace into a tight below 1 ACH home, can you talk about some of the important points, both from the firebox standpoint and from the envelope penetration standpoint?
Yeah, so the firebox, and the firebox, the codes, at least the codes in my market, are requiring combustion air be brought to the firebox. So it's an outdoor open vent that comes into the firebox that supplies combustion air. We're not using interior air for combustion of the fireplace. Number one, that's got to be number one. Number two, if you're creating negative pressures through any major You got to address that. You got to have a makeup air system in for that, so we're not pulling the dangerous stuff into the floor, right? What was your other part of it?
Building on low, just pushing that chimney stack, particularly in the case of great big wide chimneys, for example.
Yeah, those can be challenging to get airtight. You've got to spend some time on the details because you've got a wood burner. You've got some kind of either a masonry chimney. Number one, a lot of times it's a Class A stovepipe, so it's a double wall stovepipe. At least in my market, that's what we're seeing. They're expensive, but they're way cheaper than a masonry chimney and easier to replace. But where those penetrate through the air barrier, it gets warm enough where technically you're supposed to use a high temp sealant to air seal that location. Otherwise, you will have issues with a really cold enclosure when you don't have a fire on, when you're not burning.
In the performing homes and whatnot, I still think the growing trend for all of us that like fire, I'm a big fan of fire, is to move the fireplace to that 3-season room outside of the envelope. It's a nice photograph, and it's a lot less risk.
Yeah.
Whenever you can push that outside of your breathing air and your air barrier, I would encourage it. And so I'm not saying stop using fireplaces. I love them. Just put them in a different spot, and that's what I would encourage. But you can't always, we don't always get what we encourage.
Are there any makeup air systems that you know about that have a manometer like built into them? So it's not using, an electrical signal to turn on or off, but it's actually regulating pressure?
That's a widget that I don't believe exists.
I think there's a couple companies that might be working on the technology.
I could see, yeah.
Yeah, and that's where I would like to see them too. I'd rather see something based on where the pressure is in the house and equalize it. One of the issues gets to be is wind will have a weird effect on this. If you've got a 40-mile-an-hour gust, you're going to have a positive pressure on one part of the house and a negative pressure on the other side. Where's that sensor at?
Yeah.
Is that seeing something that's actually happening in the house, or is this, it's just been part of the house?
In theory, it seems like it would balance better.
You would think
You
so.
don't really know
Yes.
what combination of appliances are being turned on at any given time, which can make different pressures, which means different stop points on a damper.
Ask that question to Allison Bales. A PhD physicist might be able to tell you. That's a dumb idea. That doesn't work, but I think it's a great idea.
A lot of smart people in the expo hall. There's a gentleman by the name of Wayne, if you haven't met him before, at Life Breath. Pull him aside, don't question him in front of his coworkers. It'll probably tell you exactly what you want to hear.
Yeah. Any more questions? We got 5 more minutes.
So what do you do with a home that's got big openings? You were talking about that barn dominium, big, 3 garage doors. Let's say you've got a house that's got a really big door as part of the living space, and you've constantly got that open. Is that a negative for building tight?
No. If it's the same temperature inside and outside, same humidity, big deal. It can be open. If it's 20 below outside and the door is open, yeah, it's going to have a pretty big effect. So the issues with some of these bigger doors is they're really made for more temperate climates.
Yeah.
That's where they work best. You don't want to take one of these big 12-foot tall, 20-foot long multi-panel slide doors and try to put that in a climate zone 7 where you're trying to keep it airtight, because they're not very well air sealed. There's too many. It's too hard for them. There's too many connection points. Lift and slide, if you want a big door, Jake Bruton's got a 12-foot, 10-foot tall, or 8-foot, whatever that was.
The advancements we've had in large openings and large glazings are ridiculous. The only ones I've seen be effective are really the lift and slides. And if they're going to make the leap to have the giant wall of glass, I would encourage most of those panels to be fixed and operate the ones you're getting the joy of that, but at least we're eliminating that huge linear line of flow, and it is going to save them some bucks. So you could portion that off. You just kind of lead them into it. the decision's gonna be made, but yeah, if it's left open, let the punishment fit the crime.
Yeah, if you have a blower door and you do a lot of testing, sliding patio doors, they're a bane of my existence. I don't know how many thermal imaging photos I have of air leaking between the panes. And it's, at 0 degrees out, it shows a really nice thermal imaging photograph, and you're showing the customer, and you're, sorry, you bought a $5,000 Marvin door that's a really pretty door.
How many
But it
people
doesn't
have
perform.
seen Build Show Build Boston with Stephen Basic? Okay, it's like half the room. So we did lots of blower door tests on that house, and I think it was 0.6, and we just stopped testing. But we used the sound tester from Coltraco, and so they used sound is beyond my head for submarines, but they use it in this case. You could test each window, and so that house is the SASHCO tilted turns, and so we had that unit on. We simply closed it. We didn't lock it, right? So the handle was open, and the leakage on that was like hardly anything for the sensor to pick up, and that's without locking it in place. So, anywhere from casements to tilt and turns and lift and slides, we're happier campers. But if you go outside of that, welcome to the leaks. And again, we're okay with leaks as long as we know that they're there.
Yeah, and if you're building code, you got to hit 3 or 5 ACH 50, and that's usually the houses that are hitting that metric are the ones that are average. Actually, my climate or my market is 1.75. That's our code built house.
Plus, you're dropping your window package by having only a few of them be operable. Now you can afford your ERV.
Yeah,
Easily.
yeah. Anybody else?
Go for it, Ryan.
So I'm on the ERV train, right? I own them, I use them, I know how they work.
She's got a microphone.
I say I'm an ERV fan because I understand them, but I also do like third-party design work.
Yep.
And I have a hesitancy in our climate, in hot, humid, to recommend ERVs to people that don't understand them. Okay, so say we've got a builder, builder's doing his own house. He's interested, but he didn't really know, or say he's building a spec house, for example, right? He didn't understand the ERV. I'm introducing the concept to him. The client doesn't understand the ERV. I have a natural gut feeling that it's a less risky solution just to abandon the ERV and go with ventilating dehumidifier or a positive pressure solution in climate zone 2A. So I want to know if am I way off on this, or because ultimately we do have forensic risks with these ERVs. And if we don't see clients maintaining them, or it's not going to get tested on the back end anyway.
Yeah.
I don't want to introduce a forensic risk unless the person's ready for that solution.
So, scare the crap out of them
Yeah.
first. and yes on the dehumidification as well. Like you need that there, but that's going to be a longer conversation.
I'm one of his clients, so I'm curious.
Okay, so anyone build or live in Texas here for the room? Have you guys met the two gentlemen in front, Ryan and Kevin? So Ryan's question on ERV is kind of useless in other markets. It's very important here. And I don't have that answer other than I would still feel comfortable arguing with Ryan that their inability to understand and commission the ERV is a reason to not have the ERV.
I would disagree.
Okay.
I think they need to be educated that it's just like changing the oil in a car. It's something that needs to be done, regardless. And the equipment, don't think of the equipment as, think of the equipment as fresh air machines for the occupants. That's what it's really there for, is to make sure that they're healthy inside the home, especially when a home is super tight.
Yeah, I think that's what I was trying to say, though.
Okay.
I still want them to use, I'm not okay with the argument of not having an ARV.
Okay.
Well, we can still get it with, you know, with an April Air 8145 ventilator pushing air into the house. We still answer all those questions.
But then you have exhaust only
No, so- well, we're,
bathroom fans. Are you doing an ERV plus exhaust only?
and we could do that for high performance clients, but in the end, we have to design for people, you know, to maintain these systems, understand how they operate, and those can be very challenging as well.
That, or you find an installer or train your installer that this is the process, get them to sell a service contract to the homeowner. We're gonna come in once a year, we're gonna service your equipment, and for whatever cost it is, and that way it runs.
And what you added, Kevin, is right. What are we talking about here? Are we connecting it to our bath fans? How is that done? What is the envelope? All those variables are the right part. So,
And on a positive pressure system too, if you're gonna use it, you still have maintenance, right? You still have an intake someplace that's gotta be cleaned out.
Sure.
And that's the biggest problem with an ERV or an HRV, is that they're not cleaning that. I mean, there's filters, of course, inside, but there's probably a filter in the dehumidifier too that still needs to be changed.
The difference with the positive pressure, though, at least in our climate, is you're starting out with a positive 70 CFM, whereas an ERV, you're starting out with positive 0. Right? So you have the ability to flip negative so much faster with the ERV when you do a positive pressure solution, where if the intake gets gummed up, you might go from 70 to 50, but you're still positive. Maybe this is a humid climate thing.
Yeah, probably.
I like ERVs, right? But I think in the end, it all comes down to an energy equation,
Okay,
right? Because you're effectively reducing the loads, you're reducing the need for a dehum. And so if your client doesn't care about energy, then I think the ERV introduces forensic risk.
okay, I get it, yep.
Just a
See
thought.
that. Yeah,
It starts with a discussion, right?
yeah, yeah,
We all share experiences. Thank you, guys.
yeah, we gotta go, but thank you.
It's been a great week here at Build Show Live in Austin 2024. I want to thank one of our project underwriters, POLYGAURD, who is providing this content from our classes, which were amazing in client management, building durability, and building science, where POLYGAURD has been a leader in air and water management for a long time. We've used a lot of their below-grade water management solutions, but they brought out some great new stuff from their termite prevention to their air control products. POLYGAURD's been solving things for builders for a really long time, and we're grateful that they're still working to make our lives easier every day. Thank you to POLYGAURD, and thank you for your continued support of our educational content.